Okay. So in today's webinar, we'll be diving into a topic that's really top of mind in many enterprises, which is orchestrating agentic workflows. But specifically, we'll be looking at the role that knowledge graphs play in streamlining the implementation and the adoption of enterprise-grade AI agents in demanding use cases. And to start, let me briefly introduce our speakers. First, I'll be joined by a second Jan Ebner, Head of Product at Squirro, based in Singapore. So Jan has been at the forefront of translating enterprise requirements into AI strategy. And Jan, it's great to have you here today.
Thank you. Thank you for hosting us.
And we're also joined by Dave Clark, who is our head of innovation. Dave is a veteran in the world of knowledge graphs and semantic technology, and he joined us with our acquisition of Synaptica, which took place almost 2 years ago now. Since then, Dave has been instrumental in integrating taxonomy and ontology management into the Squirrel platform. He's also the architect behind how we ground our Gen AI and our agents so that they actually understand the business logic that they're operating in. So welcome, Dave.
Thank you, Jan, and looking forward to the questions after as well.
Great. So we have a packed 45 minutes ahead. Here's a quick, brief roadmap of our session. We'll start with a quick look at the Squirrel Foundation and how we've spent essentially decades building the foundation for this AI moment. Jan Ebner will then dive into the core challenge, which is operationalizing agentic AI. So looking at what it takes to move from fancy demos to reliable production scale deployments. Then Dave Clark will pull back the curtain on the technical scaffolding. So he'll show us the role that knowledge graphs play in providing the deterministic layer that agents need to operate reliably. And then we'll look at two practical demos, specifically focused on incident support and asset management use cases. And then finally, at the end, we'll wrap up by opening the floor for your Q&A. If you have any questions, if you look at the bottom of the menu, you should find a Q&A tab. You can enter questions in there, and then our speakers will be able to look at those in that final section. But before we dive into the how, let's talk about the who. So at Squirrel, we help organizations accelerate transformation with an enterprise AI platform that's proven, not just promised. Now, the Squirrel platform, it's specifically tailored to the needs of regulated industries, streamlining enterprise search and automating complex custom workflows. So we build on 12 years of experience in enterprise search and over 2 decades in taxonomy and ontology management. And through countless production scale deployments, we've really proven our platform's ability to meet the needs of even the most demanding organizations, including central banks, financial service providers, government agencies, and manufacturing companies, not just here in Switzerland, but across Europe, the US, Asia, and the Middle East. In this market that's crowded with enterprise AI platforms, what is it that sets Squirrel apart? It's basically the fact that our architecture is secure, private, and permissions aware by design. So whether you're deploying on premises or within a VPC, our platform, it's fully auditable at scale. And most importantly, we ground our outputs in your organization's unique enterprise ontology. So to sum up, Squirrel basically offers a robust, accurate foundation for agentic AI that your CISOs can actually sign off on. And we aren't the only ones saying that. So this past year alone, Squirrel was featured in 25 Gartner reports and positioned as a leader in 2 of their emerging market quadrants. But the real validation is really in the partnerships that we've forged. As you can see, we work with some of the most demanding organizations in the world, from central banks to global manufacturers. And these are all environments where good enough simply isn't good enough. But okay, I guess that's enough from me. Let's move on to the meat of the webinar. We'll be kicking it off with Jan Ebner, our head of products. So Jan, yeah, agentic AI, it's amazing on paper, right? But in reality, it can be a lot harder than it looks. As many organizations that we speak to on a regular basis continue to learn the hard way. Could you walk us through what it actually takes to operationalize agentic AI in these highly regulated environments?
Absolutely. Thank you very much for the introduction. Yeah, agentic AI has rapidly moved from concept to experimentation across industries. And many organizations are building pilots, many are seeing promising results. But the real question is no longer whether agents can work in general, it's how to make them work reliably in production. Excuse me. Over the past 18 months, we have seen an explosion of interest in agentic AI. And by agentic AI, we mean AI systems that not only generate answers, but also orchestrate multi-step actions within enterprise workflows. Many organizations are running pilots and many are experimenting successfully. And yet, according to Gartner, over 40% of agentic AI initiatives will be canceled by 2027. And that's not because the models don't work. It's because costs escalate, business value remains unclear, or risk controls are insufficient. So the core challenge we are observing is not AI capability. Most pilots succeed technically, but they stall when organizations try to move from experimenting into governed production-grade workflows. And the gap is not intelligence, it's like operationalization. Yeah, in experimental environments, autonomy feels powerful. You can chain prompts, you can connect APIs, you can automate sequences quickly. And in a sandbox, that often works remarkably well. But enterprise environments operate under very different constraints. So they require role-based permissions, they require deterministic control over process steps, they require traceability, and also, most importantly, auditability. So what we can see in practice is a tension. It's like experimental autonomy optimizes for flexibility and speed, and enterprise production optimizes for control, compliance, and accountability. So the real challenge is not choosing one over the other, it's combining autonomy with structure. If we accept that supervised autonomy must operate within enterprise constraints, then the next question becomes, what must exist before we deploy agentic workflows at scale? So first of all, this is the access control. Every data access and every action must respect enterprise ACLs. Agents cannot bypass existing permission models. That's very important. And the second one is data sovereignty and virtualization. Data must remain governed within its domain. We cannot introduce shadow movement or uncontrolled system interactions. And the third and the last layer is the deterministic process layer. Not to replace AI reasoning, but to constrain it within defined states and transitions. So this is critical. Unsupervised autonomy without structure creates risks. Supervised autonomy within structure creates leverage. So governance is not an add-on feature, it's a prerequisite for enterprise autonomy and eventually enterprise autonomization. So what we have seen a lot of excitement around fully autonomous AI agents, but in enterprise environments, maturity typically progresses in stages. So usually the first stage is information assistance, which is like retrieving insights, summarizing developments, and supporting awareness. The first stage is not just about delivering value quickly. It is where organizations establish the foundational capabilities like the data governance, the access control, the trustless retrieval, explainability. And those capabilities are basically the foundation that are required to be able to succeed with stages 2 and 3. So once they are established, organization can also focus on stage 2. And stage 2 in this case is like guided orchestration. It's like recommending next best actions within defined constraints, and then eventually move on to stage 3, which is controlled execution, where actions are performed, but always within governed workflows and auditability. So the key point here is that operational autonomy is not about removing human accountability. It's about automating a structured, repetitive coordination. So while preserving control over high-stakes decisions. When we look at where agentic workflows create real enterprise value, we don't start with open-ended reasoning problems. So we start with structured coordination challenges. In banking, this includes like client onboarding, remediation of incomplete submissions, or compliance monitoring and portfolio prioritization. And in private markets and sovereign wealth environments, it spans the full investment lifecycle, starting with deal sourcing and pattern detection across sectors and geographies. Due diligence across hundreds of documents and dependencies is also one of the common use cases that we see. And excuse me. And also portfolio level risk monitoring across shared exposures. In industrial and telecommunication environments, it's incident triaging, resolution coordination, and cross-team escalation. What these use cases all have in common is not creativity, it is structured cross-system coordination. And this is where agentic orchestration delivers measurable value. But the very environments where value exists are also the ones with the highest structural requirements. Means these workflows operate under real constraints. First is the access boundaries. So data visibility and actions are role-based. Agents cannot just simply access everything. This is very important. The second one is defined process states. Workflows require mandatory transitions, approvals, and sequencing. So you cannot just skip these steps. And then the third one is the business logic dependencies. Systems are interconnected usually. So once an AI action may trigger downstream implication across like multiple platforms. And last but not least, fourth, audit and compliance requirements. Every action must be traceable, defensible, and explainable. So this also goes hand in hand with the second step that you can, with the second point that you cannot just simply skip a step. So autonomy in enterprise settings cannot be freeform. It must operate within clearly defined structural boundaries. So if enterprise workflows require defined states, permission and traceability, then the next question becomes, is prompt chaining actually enough? And prompt-based orchestration is powerful for reasoning. It enables agents to interpret goals, retrieve information, and suggest next actions. But the structure in a prompt chain is implicit. It lives inside the prompt. It's not modeled, versioned, or enforceable. So enterprise workflows require explicit structure. State transitions must be defined, permission must be enforced, and also dependencies must be modeled. So this is where structured orchestration becomes critical. So the LLM proposes, and the graph governs what is allowed to happen. Yeah, so how do we operationalize this in practice at Squirro? As you can see here at the top layer, we enable retrieval across structured and unstructured data. This includes like semantic search, hybrid search, and cross-system access. And on top of that sits the conversational and agentic layer, where goals are interpreted and actions are orchestrated. But the key differentiator here lies in the enhanced capability layer. This is where taxonomy, ontology, enrichment, and the knowledge graph provide explicit structure. So the graph is basically not an add-on, it acts as a deterministic backbone that governs workflow and state transition. And critically, everything operates within enterprise-grade controls. So we always make sure to respect access management, observability, and auditability. And underneath, we integrate with existing infrastructure and foundational models. So what you are about to see is not a standalone agent, it's structured orchestration embedded into enterprise architecture. So now that we have talked about structure, defined states, permissions, dependencies, auditability, the natural question is like, where does the structure actually come from? Enterprise workflows are not improvised. They are defined by roles, transitions, and policies. If agents are to operate responsible within those workflows, it must be formally modeled. And this is where ontology, knowledge graph, and business process models and notation become critical. And now I would like to hand over to Dave Clark, who will explain how we merge probabilistic AI with deterministic models to guide agents safely.
Thanks very much, Jan. And so Squirro today is actually the merger of two companies, Squirro and Synaptica, which was a company I founded and was acquired by Squirro just over a year and a half ago. And this slide actually explains why that merger happened in the first place. It was because it needs to be a counterpoint to the very probabilistic nature of AI. And Squirro's heritage, enterprise search, evolving into a generative AI company and a platform, and moving now into Agentic. And when Gen AI was on the ascendant, I was meeting pretty much weekly with Dorian Seltz, the founder and CEO of Squirro, and we'd just have chats about how exciting Gen AI is, but also the limits and the boundaries of it. And then from my world, which is enterprise ontology and taxonomy and knowledge graphs, how we manage kind of deterministic knowledge. And out of that was a kind of better together idea, and that merged companies. But it's beyond the merging of the companies, this fusion of probabilistic and deterministic technology is what makes, I think, our solutions very powerful, and also has prompted, a very good recognition from Gartner, as Jan said at the very beginning. So this is fundamental to what we do, and the simplest explanation is sort of when probably the right answer isn't good enough in mission critical business, you need to bring in structured knowledge to get that deterministic answer. Next slide, please. Yeah, so the two Jans who in their previous introduction here have talked about this non-functional capability of Squirro, which can never be stressed enough. Many companies and businesses have been experimenting with pilots, and actually gave a talk late last year, from pilots to production, and it was just focused on this idea that you can get a lot of things going really quickly that are very impressive at small scale and in sort of functional prototype. But if you then want to get the privacy, have the security, and scale them up, that's when they simply stall and fail. And the really cool thing about Squirro is this platform of tooling that was on the previous slide that Jana had up is it's a place where businesses can develop on a really solid foundation, AI agents and knowledge base, and orchestrate all of that and content coming together in a way that can naturally scale up. And that's the foundation. It's non-functional, not as interesting in some ways, but equally as important. Next slide, please. Always my favorite slide. Okay, so it's not quite cocktail conversation, but if I try to explain to somebody what I do, what Synaptica technology does, in one line, it's we transform human knowledge, human readable knowledge, into machine readable knowledge. And we were doing that before the Gen AI wave. It's rooted in a lot of a lot of solid industry standards and so forth. But it's come of age now because AI agents can't just use their very impressive probabilistic capabilities going straight over data and produce reliable results. So having the mediation of machine readable knowledge is absolutely essential to getting good AI and good AI agents. Next slide, please. So let me elaborate on that a little bit here by being precise in what I mean by knowledge. I'm going to start by what knowledge isn't, because it isn't the same as content. It isn't the same as data or information. We kind of know what data looks like. It's the granular stuff that lives in probably relational database tables and data feeds and in individual files, let's say in digital asset management systems. So data is granular, and in and of itself, it's not intended for human consumption. It is the stuff that that information is compiled from. So information uses data, but it pulls it together in a way that it's formatted for human consumption. That formatted for human consumption could be a document, it could be a report, it could be a live query, but it's getting data and assembling it into a meaningful way for humans. That's where all of the kind of the content and the data in companies lives. And then we have knowledge, and it lives above that, because what knowledge does is it is connecting, it is joining the dots between information. So first we need to have dots in information and data, and that's labeling of data and information as concepts. And then we can join dots, and we can also bring in human experience into that. what different personas are looking for in the data and the information. So human experience is also a part of knowledge. Next slide, please. So how do we represent this machine readable knowledge? This isn't a Squirro invention. This is many, many practitioners in the industry over many, many years, creating industry standards like the Resource Description Framework, RDF, which is curated by the World Wide Web Consortium, adopted by many industries. RDF is the industry standard way of machine reasoning or the representation of machine reasoning. And that breaks down in a knowledge graph at the upper level to schema, which represents how you structure and the named properties and named relationships in an ontology, and then the named things, which is the taxonomy. So your taxonomy is going to be, product names, abstract concepts, markets, people, you name it. It is all the named things that conform to a schema that empower reasoning because of the logical structure and the semantic definition that go into that ontology. Very important. Then we have the bottom of a knowledge graph, which can be much, much bigger than the top. And in that bottom, it might be referred to as the semantic layer or the annotation graph or a metadata graph. It's basically ontology that's being connected out to data and brought back into the graph as connections between this concept is mentioned in this sentence in this document. But when you do that, you start to find other connections between different bits of data or different bits of content, and the knowledge starts to actually manifest in that bottom graph through inferencing. Next slide, please. Okay, so this is very, very important to agents. Classification actually underpins an agentic layer because if you can't see and name things precisely in processes, you can't control those processes. So we have an iterative classification and information extraction system, and the way we've designed this is to be a virtuous circle. So the ontology is used to describe and annotate data and information, the content, but in the same time as capturing all of that and putting it into the bottom of the graph, we're using Gen AI to look at that content and that data and to find new things or to find augmentations, type them back into the ontology. And of course, the enriched ontology now is more powerful in describing and identifying things in content. And so we go on this virtuous circle. Next slide, please. And next slide, please. Okay, so all these graphics are metaphors, and you can create lots of metaphors for things. But this metaphor is essentially talking about this foundation of we've got data, and then we have a semantic layer above it. And then we have agents in the agentic layer. So instead of agents just talking straight through to data and content, we now have a mediating layer called the semantic layer. And that is where the ontology lives. It's where the knowledge graph that connects data and information to the ontology lives. And that's sort of a big network, which I've got a little graphic there. The second graphic to the right is like a flow diagram, and that's because we are now putting process flow into the graph and using the graph as a means to control process flow. So above the semantic layer, we have the agentic layer. This is where agents live. This is where RAG lives, and of course, language models. And above that, we have the insights layer that is surfacing all of this to people. Next slide, please. Okay, so the Squirro view, the Squirro vision here is that agentic AI is actually at the intersection of generative AI and knowledge graphs. So knowledge graphs have been improving precision information retrieval for many, many years. What we are now doing is we're using knowledge graphs to improve the precision of workflow automation. Next slide, please. So we started doing this. We were kind of like an early adopter of doing this. And when you think about a process workflow and you start drawing little workflow diagrams, they look awfully like graphs because they are nodes, they are connections between nodes. And so we can define a workflow very naturally in a graph. There's nothing forced about it. So we did that really quickly. We took our graph editing tool and we started to build process models in it. And we did this for a real life customer where we took their ticketing support processes and system, and we modeled it in graph and we implemented it for them. And it was a fairly simple graph that was, we only needed a fairly simple graph to capture that, but the results were staggering. It improved the quality, the satisfaction of tech support ticketing incidents and closure, and it resulted in a 10x productivity gain because we were automating much, much more of the process with this very deterministic graph model behind it. So then, based on that success, the innovation team said, well, we need to do more of this, and we're going to hit more complex models, more complex processes. How are we going to deal with that? And we turned to something called the business process model notation. So again, we didn't invent the wheel, just like we use RDF. We went out and looked at a good industry proven model, which was BPMN. This defines all sorts of process stages, escalation points, validations as an abstract schema. We brought that into a graph, used it or converted it into an RDF ontology model, and then that model becomes the framework for applying it to just about any kind of process you want, and it can handle lots of complexity in that. Next slide, please. And the next one. Okay, so I'm going to very briefly describe something the innovation team did to kind of use this end to end, and then I'm going to hand back to Jan, who's going to give the industry use cases. So we said, let's put into a graph using BPMN as an ontology model the steps and processes that people go through when they create knowledge graphs, and see if we can create an agent that will build a knowledge graph for you kind of from nothing through a step-by-step guided process. So we built the process model. That didn't take very long. And in here you have got nodes of process connected to other dependent or triggered processes, and directly in the graph with clear visibility of what the process is and what the next step is, we embedded prompts, and those prompts are then called by the agents. But they're one of the virtues of doing this in graph is the transparency of the process. You can literally see the way the machine is going to think or thinks, and you can, with that transparency, you can have control. Next slide, please. So then we put a front end on this, and that front end was to be for a non-expert. So it's a conversation. Have a conversation with this agent, and it will walk you through the process flow of what a specialist taxonomist or ontologist would do, walk you through the flow with all of the trigger points and questions and so forth, and then it produces a result. So we built this. You can move straight to the next slide, please, Jan. We built this, and within minutes, you could have a conversation with this agent, and given the process flow being defined, it would build taxonomies and knowledge graph from scratch, literally from scratch. And this is something I didn't think could be done a year ago. So we live in a very exciting time. So this agent was asked to build a 3-tier clothing taxonomy and ontology model in English and Spanish with preferred labels, generate definitions. This is the beauty of Gen AI at work. And then in the human in the loop steps, we were also telling it, go deeper into this area, don't want to do baby clothing, etc. And out of all of that controlled process model, it generated an industry standard RDF ontology, and it did the whole thing in minutes. And that is the power of being able to design agentic workflow, connect it to a graph, and use Gen AI in all of the processes. So I'll hand back to Jan now, who's going to pick up with industry use cases.
All right, so thank you, Dave. I can imagine that last use case may have resonated with a lot of people who want a head start in using knowledge graphs to augment their enterprise AI solutions. As promised, we'll take the remainder of the time to look at two specific use cases. And these use cases, what they do is they replicate business process workflows that we use with our customers, but of course, using non-confidential data. The demos also build on some capabilities that are still at the cutting edge of our R&D roadmap. But to be clear, the backend components, they're all fully functional. What we're showing you, though, is a sneak peek of our next generation interface launching in Q2, which brings the agent's internal thinking to the surface, thereby making like every step of its process visible to the user. So I'll briefly set up the use case, and then I'll let Jan share what's going on in the backend, tying it to the information that he and Dave have shared until now. The first demo, it builds on a concrete incident support deployment that we enabled for a major European telco. It's the same one that Dave mentioned earlier, which compressed their ticket resolution time by 10x, improving customer satisfaction. And for this, we're going to put ourselves into the shoes of a senior delivery engineer faced with an unexpected outage of one of the instances that they manage. It's always obviously a high pressure scenario because prolonged downtime can increase the risk of customer churn. So let's take a quick look at how an agentic workflow offers support here. And as so often, it all begins with a prompt. Jan, maybe you can guide us from here on.
Exactly. So the prompt is I'm having a problem with my instance. So once I executed it, so basically what's happening here in the instance is in the background is that we on the one hand, we're retrieving the user information to double check the access rights and to which instances and data source the user is having access, as well as finding an appropriate predefined workflow that is suitable to resolve the described scenario. So those workflows are part of an agent library that we will also briefly see during the asset management demo a bit later. So once a matching workflow was identified, in this case, the one who is checking the status of an instance, an LLM orchestrated agent is taking over. So the job of the agent is to follow the predefined workflow steps that are stored and maintained in the graph and to orchestrate tasks to sub-agents and aud tools to retrieve all the required information to make an informed decision. So in our example, the agent is connecting to the monitoring systems of the identified instances and evaluated the health metrics. So then it generates the answer. And in this case, the agent identifies two instances with metrics outside the expected values. So one is the AI Studio Dev that is slower than it should be. And the other one is the Squirro classifier environment that's not responsive at all. So this information is now shown to the user together with recommended next steps. So there's still a human in the loop to confirm the execution. So in this case, we select the instance that is not responsive. And now the orchestrating agent triggers a number of tasks to retrieve all the required information to identify the root cause of the issue and to come up with a solution. So in our specific example, the agent will now trigger a tool to retrieve additional information from the monitoring logs, already has done that, and also another tool to analyze and summarize the key findings of the logs. Once that is done, the agent will consult our internal knowledge base to identify similar incidents and applied solution. So this step in particular is interesting because of the implication that it brings. So what we see here is called a reinforcement learning cycle. So every incident that is being handled by the agent and the feedback that we receive from the user during the process expands the knowledge base the agent can leverage to resolve incidents. So to simplify what I just said, the agent will become smarter and better the more the agent itself is being used. So after the issue was identified, the agent will also leverage this knowledge base to propose a solution. Yeah, so now we identify the issue. In this case, the root cause seems to be an expired SSL certificate. And the agent now suggests a server restart. In our example, the agent has the right tools to execute the recommended solution. So here to restart the server itself. In case there is no tool available to execute the resolution of the issue, the agent will provide a step-by-step guidance on how to resolve it manually, or at the last step of escalation, it will file a ticket and involve a human support agent. So yeah, Exactly. So after the approval of the end user to execute the restart of the affected instance, the agent, what we see here, will trigger the required steps to restart the server and also once more retrieves the server logs to ensure that the issue actually was resolved before requesting feedback from the user. So this is what we see here. Yeah, now it summarizes the execution and said that it's verified that it's working, and then ask the user if the issue was resolved. Yeah, so this is all the information that we have gathered. Yeah, what we also do, moreover, we also expose all the retrieve and process information to the end user to ensure, on the one hand, that the process itself is tangible, but also that it's traceable, so that we gathered all the required information. So in case a support agent or someone from the engineering team will want to look at this case, that he can see like traceable what happened, why has it happened, and exactly. So as a last step, the agent will now summarize the conversation and creates an incident report that gets logged as a ticket. So moreover, the incident report will also be enriched with additional metadata and added to our knowledge base so it can be used as context for the future incidents requests. So what we have deployed the process that you have seen here. The whole back functionality is functional. A few months ago, for the incident support team of a global telecommunication provider, as mentioned earlier. And so far, we have received the feedback that up to 70% of the incident support requests can be resolved with any further human support agent involvement. So this means that the solution does not completely eliminate the need for humans in the loop, but drastically reduces the workload and lets specialists focus on cases that are more complex. And in the future, with the before explained reinforcement learning cycle, we are confident to increase that number to over 90%.
Okay, that's great. And thank you, Jan. Let's move on to our second demo. So this one is modeled after a deployment for a major US wealth management firm. And here we'll be looking at a tailored advisor dashboard. Let's take a look. Jan, could you take us through the key components that we see here?
Absolutely. So what we see here is the start dashboard for our upcoming next gen product, which includes tailor-made insights for every user, gathering, processing, and analyzing data from various data sources, while of course respecting all ACL requirements across those data sources. So this can include like SharePoint, Google Drive, or any other internal and external data source. And you may have also already noticed the adverse media alert or the portfolio concentration risk alert right in the middle of the screen. So those notifications are generated by workflows that are running on a scheduled interval in the background, processing new data points and bringing the information to the user without the need for search queries. So with this approach, we are moving one step closer to our vision of the end of search. However, we believe that not a fully autonomization is what will drive the business value in the coming years, but personalization of content and the automation of repetitive tasks and knowledge retrieval will bring a return of investment instead. So let us take a look how such an end user support can look like in the asset management space. If we switch to the chat dashboard, which is the main interaction page in our product, the user has the possibility to actively interact with Squirro as we already have seen in the previous demo. So in this case, I asked what key accounts do I need to focus on this week? So while this example question can also be automated in the background and ported to the starting dashboard, the user within Squirro, of course, also has the possibility to leverage our agentic workflow framework in any kind of question. So this is just an example question. And what's happening here in the backend process is similar to what we have already seen during the incident support demo. As a first step, we again retrieved the help with the help of the knowledge graph, the user information to see which accounts he's working on, to which data he has access. And afterwards, the agent will orchestrate tasks to respective sub-agents and tools to compile an overview of the end user's accounts, as well as compiling a status based on the retrieved information. So when we now click on the data systems company, it will forward us to an account details overview page. And besides key information around the account, we can also find 3 recommended workflows that suits the specific needs of our end user. So those can range from identifying internal champions to sketching a follow-up meeting to improve client relationship. So we also provide, as you can see here, overview based on the PPMN structure that Dave explained earlier. so the user can understand what steps are part of the workflow. And every step in the workflow can also be broken down into additional information, showing the user exactly what information will be processed and what what the desired outcome for each step is. So if we decide to execute the workflow, the agent will schedule a meeting with the key stakeholders and also summarize the main action points for the user to discuss. So why the key value add of this example workflow that we just showed is to evaluate the key accounts of the user and to suggest suitable actions. We have also covered more complex workflows for big financial institutions around the world, focusing on finding investment opportunities and help them to proactively identifying risk. Maybe as last example here, identifying potential overexposures in certain industries or countries where regulatory changes could have served as a trigger, as an example.
All right, thank you, Jan. So these demos, they show what's possible when you have the right foundation, and that's really essential. During this presentation, we've covered a lot of ground, from operationalizing agents in high-stakes environments to the role that knowledge graphs play in translating human processes into reliable actions. I'm sorry. Now, let's take a quick look at the strategic takeaways for your AI roadmap. First of all, foundation first. I mean, that's clear. Without granular access controls and enterprise-grade security, an agent is basically just a security leak waiting to happen. So good luck getting that past your chief information security officer, for example. Structure is safety. So the deterministic semantic layer ensures that the agent follows your business rules for complex workflows rather than simply guessing the next step. That can be detrimental to your performance, of course. Graphs provide the blueprint, the new BPMN ontology, the new way of applying it that we've presented here. It supports rapid modeling of complex multi-step processes with full transparency and control. And behind all that kind of lurks this do-it-yourself trap. So agentic automation is deceptively hard. There are so many layers of hidden complexity in orchestration and architecture that often derail in-house efforts. So it's something to be aware of before embarking on to challenging adventures on your own. So today we showed you how agentic workflows are supporting other organizations in their operations. Of course, the real value comes from seeing this architecture applied to your data and your specific friction points. So if you're ready to discuss your AI roadmap and see how the Squirro platform can add value to your business, please reach out to our team. You can scan this QR code displayed on the screen, or when you receive the slides later on, you'll be able to access the QR code from there as well. And with that, we've reached the end of the presentation. We're exactly 44 minutes through, so good timing. For the Q&A session, we're also joined by our Vice President of Sales Europe, Domenico Lapera, and for customer-related requests, and our CTO, Sarab Jain, for more technical questions. So welcome, Domenico. Welcome, Sarab. Thanks for joining us for the Q&A session.
Thank you, Jan.
Hey, guys.
Thank you. Welcome all.
So I'll let you guys take a look at the Q&A yourselves and pick and choose questions to your liking.
Yep. There's a question in about I think it must have been on my pyramid chart. There was RDF and LPG. Did you want to fill that, Domenico? Do you want me to fill that? I'm very happy to.
Please do, Dave. You're the expert.
Okay. So in the graph database world, there's kind of like a clear division between RDF graph databases, which is based on the resource description framework from the World Wide Web Consortium, and also LPG, which stands for Labeled Property Graph. I'll just use a brand name to give you an example of an LPG. So Neo4j is a very, very well-known labeled property graph, leading property graph database. And each thing has a little bit of a sort of pros and cons. So if I could simplify that, RDF is best for machine reasoning. It's actually designed for this machine readable logical processors and semantic definition. It's also an industry standard, open standard. So the RDF model is not proprietary at all. LPG is a little bit more used for handling, let's say, data graphs rather than structured knowledge graphs, rather than ontology. But each one has its merits. Now, in the diagram that I put up, the Squirro way we're doing this is we're going to do reasoning up at the top in RDF because that's what it's designed for. So our ontologies are going to stay in RDF at the top of the graph. But then when we get to the big graph at the bottom, which is where we might store annotations, the semantic layer, we're neutral. We could do that in RDF, we could do that in LPG. And why that matters is just because we talk to customers who may have already invested in some Neo4j or invested in some labeled property graph, and that's fine. We're going to do reasoning in RDF, and we have an RDF graph database behind our taxonomy ontology systems. But we're quite neutral. So that's hopefully answered that. By the way, anybody who has questions posted, I see a lot coming in now that we don't get to on this call. We will answer those questions by email afterwards. But we'll move on to a different one now. Let's just see.
So I can take a question around we want to connect external signals, which is news, market prices, with internal data and get automatic alerts when patterns emerge. How much of that is out of the box versus custom development? So maybe a few sentences here. So Squirro as a platform, we have built it to be a very pluggable and modular platform, which means that you can always connect new data sources that we may not have connected to before. You can provide new enrichments using ML models that we may not have done before, and all of that. Having said that, we still have a rich library of pre-built connectors that we have done. So depending on which news source you want to get access to and which market prices APIs you want to get access to, we may already have the connectors to those, and that would be a plug and play. And the automatic alerting in terms of emails is also an out-of-the-box feature. So yes, that would be possible out of the box depending on connectors. And if not, we will easily be able to develop new connectors for specific logic. Then I see one more question about, so just for me to reiterate the question, I'm working on using knowledge graphs to represent and connect enterprise data on a project. From your experience, how does the graph concept compare to classical vector stores and other options for RAG solutions in terms of information retrieval? And are you using a combination of these approaches on your platform? So yes, we are using a combination of these approaches in our platform. Originally, Squirro worked quite a lot in the space of information retrieval using information retrieval on the unstructured data, which uses technologies like keyword search, vector search, and a combination of those. But in the last 3 to 4 years, we started to hit limits on that approach, especially for situations where accuracy was extremely important. So where we are using knowledge graphs is basically 2 cases. First use case is when we have a lot of structured information, facts which are in the knowledge graph, and we want to pull these facts out automatically. That is the first use case where we are using knowledge graphs. And the second use case is where we are using the knowledge graphs to expand or refine the search space into the unstructured set using traditional information retrieval techniques. So for example, if you ask a question like, hey, I want to understand all that is attached with this particular client. We may go to the knowledge graph and resolve all the sub entities of that client, because that's a very structured information in the knowledge graph, and then still go and do the traditional information retrieval. So it's a combination of both.
Thanks, Jan. I'm going to dive in with a couple of quick ones, and then Domenico, I'm going to actually bounce one over that's ideal for you. So there's a question: are you concerned that LLMs might start integrating with or evolving into knowledge graphs? Not at all concerned. That's exactly what we've done, is kind of integrated the Gen AI LLMs with knowledge graphs, and but we're controlling that process so that we're getting the very best of the probabilistic and the very best of the deterministic in a highly kind of deliberate and curated way. If you look at not just what I will say, but just look at what various analysts and the industry gurus out there have commented, LLMs are fundamentally not reasoning systems. They are natural language understanding systems, and they are natural language generating systems, and they do this to a level I couldn't have imagined was possible a while ago. So they're beautiful and brilliant at doing that. But knowledge graphs are the place where you can define the semantics of a particular business. Remember that LLMs are based on general knowledge. In enterprise taxonomy ontology, you define the semantics of a particular business, and you build into that not just what is in content. And this is why I said knowledge is not just about what you find in data. It's also what are the humans in that enterprise, what are their experiences, what are they looking for, how you organize knowledge is coming from the practitioners and the subject matter experts and getting put into a knowledge graph, and it's not coming out of general language models. So not concerned. In fact, the value that we are creating right now is by creating that intersection between them. One other little quick question to answer is, did you publish the BPMN ontology? We haven't published the ontology. BPMN is a framework you can find online in various formats. It has been converted also into an ontology, an OWL ontology, and that's what we're using. Anyone wants to take a deep dive into that, we can have a session with you and show you how that works. But that's been converted. And the question, I think, if I can bounce this over to you, Domenico, is in your conversations with prospects and customers, where are you seeing the most urgent demand for agentic workflow? So perhaps a little bit of commentary on what you're seeing in the marketplace.
Oh, thank you, Dave. Oh, wow. Yeah, that's a very good question. And yeah, I'm involved in conversation with prospects and clients every day. And I would say the interest is all over the place. Typically, the cases that get more traction and attention are the ones where we can clearly identify a good return on the investment. So everything that revolves around service desks, ticketing, claims management is an area where it's relatively easy to prove that investing into an agentic system will deliver significant results. So that's one of the applications that is keeping us busy across the different industries. Of course, financial services is one of the industries in which we work the most, but not only, also traditional banking when the volumes are very high. We are working right now on a claim management case for credit cards. That is very, very interesting for that case. Other areas where usually we get a lot of traction is about sales efficiency, so integrations with CRMs, but combining the CRM with your knowledge base, maybe even the core banking system or the core systems, the core ERP systems that store information about your procedures, how you treat your client data. That can be super powerful, and we have a couple of very interesting applications that also delivered significant saving in terms of times. So sales efficiency, we want to empower your sales force to work more productively, to acquire new clients faster, to reach out faster, and the applications are very advanced in that space. We're not the only one working in that field, but our secret sauce is really combining the probabilistic and the deterministic, and what David been explaining today about the usage of the graph. So the way we can structure the process to follow some rules while at the same time using the power of the LLM are proving very, very beneficial for our clients. And lastly, I will say another area that gets a lot of traction is automating requests about storing knowledge. A use case that is getting a lot of traction nowadays is that because of the aging workforce, we're getting a generation that is retiring, and a couple of companies are really worried about losing the knowledge that those people have been accumulating during years and years of service. So companies want to be aggressive in saving costs and accelerating those retiring processes, but on the other side, they want to retain this knowledge, and knowledge is scattered around systems. And what we are building together with a couple of clients is really a system that can collect data from interviews, different blog posts, knowledge management systems, and then treat it, store it in a graph so that they can be reused, not only to train new employees that will be joining, but also to automate a good portion of the job that these individuals were performing. I hope that was a good answer, but if you have any follow-up questions, please post it on the chat. I'm not sure we're going to have time today, but we will definitely follow up after this meeting.
Okay, so yeah, we are coming up on time. We have 2 minutes left. And as Domenico said, well, we couldn't get to every single question. We will be sure to get back to you by email. So there's a lot of interesting questions. Thanks for all the input that you provided, and thanks for all the answers, Domenico, Sarab, Dave, and Jan. So yeah, as mentioned, the challenge isn't just about what an agent can do. It's really about ensuring that it accurately, securely, and reliably accomplishes what it's meant to do in a compliant and auditable way. And that's really the gap that we're trying to bridge with knowledge graphs by combining knowledge graphs and the enterprise AI in this way. So we hope that this has been an informative session for you, that you have some good takeaways from it. As mentioned, please don't hesitate to reach out if you would like to learn more. So our subject matter experts will be available for you via the contact QR code shared earlier, and you'll also be receiving some follow-up communications after in the wake of this presentation. Yeah, and with that, all I can say is thank you again, and stay tuned for the next similar session coming up in the coming weeks. There will be more.